Welcome. In this video, we're going to go over an application of vectors. So an airplane flies horizontally from west to east at 200 miles per hour relative to the air. If it flies a steady 25 miles per hour, in a steady 25 mile per hour wind that blows horizontally towards the southwest, 30 degrees south of west, find the speed and direction of the airplane relative to the ground. So to begin, a picture will help us out. So this is north, this is south here, and then we have east and west. And we're told, here we are, the plane has this velocity. So this is the velocity. So that would look like this. It's flying west, so from here to here, west to east. And I'm going to call this vector v, and I know that the magnitude of v is equal to 200. So this is the airplane. And there we are, is my little sketch of an airplane. Now we're also told that a wind is blowing, so the wind is at a steady 25 miles per hour, and it's going southwest, 30 degrees south of west. So west is in this direction, and we want to look at 30 degrees south of west. That would look like this. And I know that the magnitude of this wind vector here is 25. So our goal is to find the speed and direction of the airplane relative to the ground. And that would look like this. And I'll call this vector G. So let's discuss a step-by-step approach to solving this problem, keeping in mind that our goal is we want to find this vector G, and we're going to use vector addition. And why are we using vector addition? Well, from this sketch we can tell that v plus w is equal to g. Okay, so the first thing we're going to do is the easiest. Let's find the components of v. Well, to do so, I'm going to draw a really light axis. Okay, and this is the x-axis, this is the y-axis. And if I were to put this vector v on this axis, which using my technology I can just literally move it. There we are. I know that the magnitude of this vector v is equal to 200. That means this point right here on the axis has to be 200. Well, that tells me that v here has an x component of 200 and a y component of 0. Okay, so step one is done. We have found the components of the vector v. Okay, let's do the same thing now. That is, let's find the components of vector w. And for this one, I'm going to go ahead and draw another axis. Okay, I went ahead and sketched my axis, and I'm going to do the same thing now where I place this vector here, starting at the origin. And I've selected my vector, and I can move it here. And now my sketch was clearly off. This doesn't look like 30 degrees, so I'm going to quickly just fix that. It doesn't look like 30 degrees. It really should be more like this. There we go. And I'm going to fix it here as well. All right, now you didn't have to fix it on yours, but it would really bug me to see this here and say it's, this is 30 degrees when that wasn't looking like 30 degrees. So let me label what I mean and what is 30 degrees. This is 30 degrees. So that means this angle starting from in standard position here is 180 plus 30. So this is 210 degrees. And now let's figure out what the components of W are. And remember, each vector has an x component and a y component. So my x component I can find by starting at the vector tip and drawing a line that intersects the x-axis at a right angle. Here this is a triangle, and actually I'm going to use this for both components. So what I mean, this that I'm highlighting in yellow, well, that's the x component of my vector right there. And this one that I'm highlighting in blue, which I can equivalently highlight here, well, that's the y component of this vector. So let's start by thinking, well, how can we find the x component? We're going to need to use trigonometry. So this side here, oh, excuse me, that's the y component. This side here is adjacent to my angle. So I know that cosine, now which angle should I use, 30 or 210 degrees? I'm going to use this 210 one, since that'll accurately give me the sign, positive or negative, of the cosine and the sine, that is the x component and the y component respectively, in quadrant 3. So cosine of 210 degrees is equal to the adjacent over the hypotenuse. So the adjacent is the x component, and what is the hypotenuse? Well, we know that this has a magnitude of 25. So this tells me that the x component is equal to 25 times cosine of 210 degrees, and that's going to work out to be exactly negative 25 times root 3 over 2, which is approximately negative 21.65. And now we can do the same thing for the y component. Take a moment, pause your video, and see if you can set up the required trigonometric function to solve for this y component here. Okay, you should have attempted to set this up. And what we want is sine of 210 degrees equals opposite, which is my y component, over 25, which is the magnitude of w, which is my hypotenuse. This leaves me with the y component is equal to 25 sine of 210 degrees. That is 25 times negative 1/2. So my y component is equal to negative 12.5. That tells me that the vector w is equal to negative 21.65, comma, negative 12.5. All right, now we have finished this one too. We found the components of vector w, so let's label this with a 2 and move on to the next step. And that is we're going to finally use vector addition to find the vector g. So use our work from 1 and 2 to find vector g. And I'll do that right below here. So v is equal to 200, comma 0. W is equal to negative 21.65, comma negative 12.5. So sum them up. That's equal to 200, comma 0 plus negative 21.65, comma negative 12.5. And of course, we know that this is equal to g. So vector g is equal to 200 minus 21.65, comma negative 12.5. And this works out to be 178.35, comma negative 12.5. So there we are. We have vector g. Okay, so I'm going to split this here so I can continue our steps. So these are our steps, and this may have gotten a little messy, so these are our steps, or our procedure, I guess. And I'll keep going with that here. These are the steps to the solution. So our steps continued. Okay, and we're on to step 4. That is, we want to find the speed of the airplane relative to the ground. So the speed of the airplane is going to be the magnitude of g. That's the speed of the plane relative to the ground. So we want to compute this. All right, well, that will not be difficult. So the magnitude of G is equal to the square root of 178.35 squared plus negative 12.5 squared. And that works out to be about 178.79 miles per hour. All right, so let's now find the direction of of G, vector G, and we're going to need to use trigonometry for this. So we want to use trig to determine the direction of vector G. And again, I'm going to make a sketch. So for my sketch, and I'll start it here, I'm going to keep in mind what vector G looked like, what it looked like originally. So there we are. There is vector G on an XY axis. And I'm going to do the same thing I did already. Start a line here that intersects the axes at a right angle. Now, we want the direction of G, so we're looking for this angle here, this angle theta. Well, what do we know about G? Well, we know that the x component of G is equal to 178.35. So we know that. And we also know that the y component of G is equal to negative 12.5. So let's look at the tangent function. That is, tangent of this angle theta is equal to opposite over adjacent. So g of y over gx. So tangent of theta is equal to 178.35 divided by negative 12.5. That tells me that theta is equal to tangent inverse of this ratio. So theta is approximately negative 4.01 degrees, and I'm just going to round that to negative 4 degrees. And now what direction is that? Well, this is south and east, so 4 degrees southeast. Let's go ahead and write out our conclusion now. That is, the plane is flying relative to the ground at a speed of about 179 miles per hour with a direction of 4 degrees south of east. All right, everybody, keep calm and math on.